some way, not in every way, because VMware gives us the power to quickly deploy. Considering you have all the hardware pitch in, your cluster has enough resources, and once you receive the architecture, you just quickly utilize your golden image and deploy the VMs. And then again, manual things were happening. Still the manual things were happening. You are deploying image manually. You are deploying software manually, and all the configuration part were happening manually. Again, this process were also taking days or weeks. If less than completely bare metal provisioning, this process was also taking days. So I will be discussing something about the challenges in that environment, and how infrastructure, what is infrastructure as code, what is it, how it helps, what are the advantages, and the best practices and methods and all those things. So what was the challenges without dynamic infrastructure? As the VMware pitched into the IT industry, the provisioning of applications took place much faster than the legacy environment. So we have our cluster, the resources in our hand. We have enough capacity. We quickly deploy multiple VMs all the time. We did configuration on top of that. So what were the challenges in that? So with number of servers being deployed and multiple application being deployed, the server sprawl took place. There were multiple servers being deployed here and there, and the configuration started missing. That where configuration drift started. Suppose you have one server for one application where Java 1.5 is running. Then someday some developer came in that they are having some issues with one of the server, and you just chime in, the troubleshooting part happened, and you just updated some registry setting, or you changed Java version, and that piece of software worked fine, and you just close the ticket, you are done. But this happened on a large scale. You have now hundreds of servers which are different from other hundreds of servers, and even thousands of servers in a large environment. So this configuration drift makes it impossible to troubleshoot all the time. I'm sure all of you have seen here where the development team deployed application and they said it was running fine in staging, why it went in QA and in perf environment, why it crashed in production environment. So this was the reason. There was a configuration drift, your Java version or multiple application, your database server or whatever registry setting you have changed, but you didn't even remember because it was a one-time job to troubleshoot the environment, and that crashed the environment. So this configuration drift was happening all across. And then there are Snowflake servers. What are Snowflake server? You might have seen some of the production environment where everyone is afraid to touch it. When you are patching it, when you are doing any type of changes to that environment, you are very much afraid to not touch it. It is running as it is. You took it once, once it is down, you are afraid whether it will come back again or not. Everyone has seen that environment, right? So these were the challenges when we perform all the things manually. The environment is completely unstable on multiple front. You have some version of software running somewhere, and some other version of software running somewhere. So these three were the major challenges which we all face when we deploy manually. So what is IAC? How IAC resolved all these things? Last couple of years or 3 years back or 4 years back, it all started where everyone started talking about DevOps and all other things, right? And infrastructure as code, I would say, is one of the key practices. If you do not have IAC, you don't think about the entire DevOps cycle, because until unless your infrastructure is automated, there's no way your development or DevOps team can work through their development cycle or their pipeline. So all these things can be resolved with IAC, and IAC is one of the key practices. If you really want to have your DevOps cycle, proper DevOps cycle, you must have IAC. You don't talk about serverless architecture or microservices until your IAC is in place. So how is it different from automation? We are already using, many of us are already using, should be using Power CLI scripts or PowerShell script to just deploy the VM or configure something. So how it is different from automation? In automation, you are just doing a single task. You are running your script manually. You are making changes to script, but you are not, you as a person, suppose if you do not have a common repository, you have made some changes to your code for running particular changes in your environment. But after few months back, you have to run again those. the other team member wouldn't be having that. Something sort of that happens. You need to make changes over the time, but those are not in sync. You know that how before running this next time I'll make these changes. So this is different from automation, simple automation, simple scripting and all these things, right? So finally, what is IAC? You apply all the software engineering tools and practices. What are software engineering tools and practices? Any application or product is created. You work with development team. You have seen they have a version controlling system. They have a pipeline setup where they test the environment in QA, staging, perf, and then they move it to prod. And all those things happen in collaboration. So, right, all the software practices we are applying to now infrastructure. Now we are also treating entire infrastructure as software. You might have seen, I have just asked, like, is the API open, API are exposed or not? Because most of the deployment now happening, or the organization are moving if not happening. Somewhere some sort of R&D might be, POC might be going on how to automate the entire thing. So all the practices of software are being applied to infrastructure. So your entire deployment of infrastructure for developer team goes through the software cycle. I'll discuss in detail again how is it achieved. So obviously, what are the advantages? We remediate the challenges, we overcome the challenges. Apart from that, your cost is reduced. For example, how the cost is reduced, I'll give our example. In our organization, just 2 years back or 3 years back, we get the similar way as I discussed. We get the architecture documents from the infrastructure architect, and the document contains all the detail. You need 10 web server, 10 application server, 5 database server, and then operating system, what operating system is required, what software are required on top of that, and you proceed with the deployment, right? And you hand over it. So in last 3 to 4 years, our platform operating system team, I think our deployment increased almost 10 times or 15 times, but our team reduced by 30 or 40%. So this cost is one more factor here. How it is reduced? Because we are not treating infrastructure as a code. The entire deployment, operating system team is not involved. Network team is not involved. Storage team is not involved. We just once configure the capacity. Everything is going on. Developer comes in, chimes in, deploy a VM. He get the access. DNS entry is being made. SCOM entry is being made, and monitoring started happening. The backup is enabled. Earlier, one person from operating system team should be working, one person from backup team should be working, one person from storage team should be working. And these all resources were required in terms of time and in terms of cost, right? Speed, as I talk about, we are deploying around 30% more VMs than we are deploying around a couple of years back, and team has been reduced. The speed, obviously the speed is a factor here. Developer just deploys his environment, he don't even talk to the infrastructure team. Security, when you have everything in a code, in a single pane of glass, you are in manual environment, what you are doing, you work with some of the developers, you give access to, on their demand, you close the ticket. You do not have a single pane of glass. You work on some issue and presented the security, changes the security settings so that the server is fine with the access, the user is fine with the access. You don't have a single pane of glass which server actually has what amount of security in it. But now when you treat everything as a code, the developer deploys the VM, it works automatically, it checks the developer's BU and which group should have access. So you know if this BU was selected, this developer has deployed it, the group which should have access will be having access and no other group will have access to it. If developer is not able to log in, you might check at that time. Developer may say that I'm not able to log in or to the server, or my application is not connecting through this port. You can check through the code whether everything is right or something has been wrong with the code or it's user issues, right? You never logged into the system. One aspect of IAC is you never logged into the system. You don't do anything manually. Whatever changes you make in the code, and you have all the security setting on a single pane of glass. Configuration consistency. So as I talked, all the servers are going through your golden images. All the settings are going through code. The code is pulling up the image. So everything, every software on top of it, then again configuration software, we'll talk about what are the software, IAC software, we'll talk about it later. Those are deploying the software with the settings that you have given. You are managing the version control as well. So everything is in sync with all the other server in environment. Whatever changes happens on the all, happens on all the servers. It doesn't happen on individual server. Okay, so what are the approach? We basically IAC is divided into two approach. One is procedural, and the other is functional. So imperative and declarative. So what are these things? There are tools which are based on imperative approach. There are tools which are based on declarative approach. In a real scenario, in a practical scenario, you will be using both of these because something is being done by the tools which are using imperative and some things are being done by tools which are using procedural approach. What is imperative and what are procedural functional approach? Say in procedural approach, say you want to go somewhere or someone asks you want to go somewhere, you ask directions from people, how to go it. Someone says take left, then take right, then take again left, then take again right, and you reach the destination. In declarative approach, you sit in a Uber cab, set the destination, and you reach the destination. This is what declarative and functional approach is. Again, the tools, basically, as I discuss imperative and functional approach, this push versus pull model, which these tools works on. Some tools have their agent installed on server, for example, Puppet. You are installing agent on all the servers which you are deploying. Then that agent is doing your software configuration, sending back all the configuration to you in a monitoring tool, which you can see and check all the configuration consistency, right? Then there is a push-based method. Sorry, I was talking about pull-based method. Now, push-based method, we are talking about Ansible or Terraform, where you just give a declarative approach or a master client connection is not there. You do not have to have install a agent on your end users VMs or the VMs you are managing. You just deploy a script that goes through SSH and deploys the software on top of it. No agent is installed on it on any other server. So you do not have a master. Any server can become an Ansible master actually. So it's just another Ansible node which can just perform your automation thing. So what are the best practices? So as I talk about, when we treat everything as a code, you should have a code, and that code should be your definition file, where it can be in multiple format. It can be JSON, it can be YAML, right? So these definition file, when we talk about infrastructure as code, how infra guys should chime into that? You might feel like if we are talking everything as a code, then where do we come in picture as an administrator? So basically all the software which we talk about, which we like, okay, so these are the software which we talk about. They have some sort of, basically you might be working with 90% of the time JSON or YAML. Then Terraform is there, which have their own configuration languages. Again, these are all based on either Python or Golang or something where we cannot chime in, but we can chime in when we have a YAML format where we give a simple text kind of coding. You just mentioned the host should be this, and it should install SQL Server. It should pull up the repo from here. So it's easy for us. So these tools provide that abstraction layer where a simple guy, a normal, not a coder, can code for your environment, and infrastructure guys can work as a coder. So we maintain a definition file for these softwares. How do we maintain it? We have versioning and a version control system. Every software which is being deployed anywhere has some sort of version controlling system. Like we used to say, like VMware, we are working vSphere 6.5, then vSphere 6.7 is there. So they too have maintained a code for that with the version. This is 6.5 version, this is 6.7 version, and application is built on top of it, right? If you want to go to back to 6.5, there is a code for 6.5, but suppose 6.7 is some application, or Facebook have launched a new feature and it fails, it start crashing Facebook, they just roll back to other previous version, right? So you maintain your code in a definition file and you version that. You have deployed SQL 2012 somewhere. When you move to SQL 2016, you have changed the version in your code as well, that this is now our version 1.2. So you have you have the picture, what all servers are running on year 2012, what are server running on 2016, and or not just SQL, all other software along with it, right? So this is just example for SQL. Now self-document systems and process. In a manual approach, we have a lot of manual documentation. We deploy a ESXi box or a VM. We have around 30-40 pages manual document, right? And over the time, those sort of documents do not get updated. We all have seen that, right? Over the time, they do not get updated. The new member chimes in and he is unsure what to do now, because those documents are too complex to be updated all the times, right? So all of us might be having some documents for deployment that should be around 5 or 6 year old, while our deployment is completely changed, right? In a infrastructure as code setting, we do not make much documents. A minimum basic document, everything is written in code. Any new person onboarded on team, he just look at the code, he knows what code is doing. So the minimum the document and the better your code is explained, you do not have that drift. Now in any software, we test the software before moving to the next cycle. Same happens in our infrastructure as code thing. We treat everything as software. We write our definition file, put it in version controlling system. We make a new definition file. We make it a new version control. We give a new version. Then we test it again. The entire DevOps CI/CD pipeline, which happens in software nowadays, we use that in infrastructure as well. We treat that against our test environment. We test them again our development environment. Once it is all good, then we open it to developers to go ahead and deploy the environment. Again, the small changes rather than wedges. When we talk about true agile system, we have also seen software development life cycle, where the entire team works for 2 months or 3 months on one particular module and then push it to the production, right? Or even in their test environment. This caused a lot of issue, and the agile came in picture. So what developers started, they just started creating a smaller modules and started the update. So they know when the module fails, they know where actually they are failing, right? And to trace back, they don't have to do the entire rollback of the software. So these are some major tools. I would say I could have involved Docker here as well, because it also changes, it also works on code, right? You have a Docker image file and all those things. So these are the major when we talk about typical infrastructure as a code, where we are deploying the VMs and all other things. These are the major tools. Terraform take one step ahead in practical sense when we talk about the cloud environment. You can deploy entire AWS environment from Terraform. You again follow the same practice. They have their HashiCorp configuration language, which is quite easy. You just have a provider, a VMware or vSphere. You have a provider AWS, and you give the details what you need. You need this much amount of instances. You need this networking setup. You need this auto scaling. How it should be auto-scaled and all other features you just described in the configuration language file and deploy it. Any changes, you then keep that configuration file in your Git repo or in stash, wherever GitHub or stash, and then you have everything in place, right? Same goes with Ansible. Ansible works on a procedural approach. So how Ansible works, you say, okay, deploy this EC2 instance or this particular VM on vSphere environment, and then deploy this software on top of it. You give step-by-step direction. You miss the direction, you lose your configuration. It fails, right? So Terraform works on descriptive environment. These are the some major config tools comparison right now. Yeah, so one thing, I think these are pretty much self-explanatory, but infrastructure, when we talk about mutable and immutable, in traditional sense, mutable works fine. You deploy your EC2 instances or you deploy your VM, and then you move on ahead and deploy more, right? That's mutable infrastructure. You configure something, and then you troubleshoot something that goes through the mutable infrastructure. With immutable, we don't troubleshoot anything. Immutable goes, and when you are doing a new deployment, you are not upgrading your actual existing server. You just do a new deployment of your fresh server with fresh application installed, and you are not bothered about troubleshooting or upgrading your existing environment in a brownfield, greenfield deployment sort of environment. So how we are using it? We have a private cloud setup. I think we realize also serves this purpose. They are also now, they also have opened their API, exposed their API now, and they are also Blueprint as a code thing is involved, right? So we are using Ansible. We were earlier using vRealize automation as well. We moved to Ansible. We have vCenter and AWS as well. Puppet, PowerShell, Stress, how these are working. We have a front-end design where any cloud happens. It can be, you can consider it the screen of your vRealize automation or AWS or Azure or anywhere. We have similar kind of front-end exposed. So a developer goes in, select all the details, what kind of server he needs, what kind of software he needs on top of that, and whether he needs backup or not, what environment will it go in, production or testing or wherever, and what is his business unit, so we can cross charge them. So this is our front end. Now this payload is being passed to your Ansible server. After the Ansible server takes the payload, it checks all the details and deploy it to concerned environment. It can be VMware, it can be AWS. This again deploy their VM on the vCenter, and once that is deployed, a PowerShell module is also run, which makes sure that all the DNS entries are in place, all the AD groups have the access which are required, and then Puppet agents. Ansible just install the Puppet agent, and that Puppet agents goes and install the required software. And everything is maintained, as I told you, everything is maintained in a Git repo, the Bitbucket or stress now, what we call it. So it's a tool from Atlassian for maintaining version control system. So these are pretty much easy tool users. I'm not sure how many of you have worked with Git. So on the back end, they are just using Git, right? So your version control system, you make any changes to your code. Suppose you have a template changed, and you just change the name of template in code. You have a latest updated template, and you just change the version. You test it against a product testing environment. Once it is done, you merge the branch to your production environment. So ultimately, the VM is deployed. Now, if these things should have been done manually, you would have deployed a VM, you would have deployed a software, you would then work with a developer to give the access to the development team. Then you would work with backup team to enable the backup for the server, and everything should have been done manually. Right now, there are around 40 or 50 VMs are being deployed daily. Just imagine, and we are not even bothered whether they are being deployed or not. VMware team or operating system teams, we get to know only when there is some issue, because in these cases, as I said, there is no configuration drift. Either the provisioning fail, or it gets provisioned if everything is good. So if something fails, then only we get to know this is failed. Check whether your VMware environment is up, whether something is wrong with your DNS or something like that, right? Earlier, it should have been a long cycle. Just imagine for deploying 20, 30 servers or 40 servers a day, and decommissioning many of them as well, because it's now on demand. Developers just test a minor change on a deploy a server, test minor changes, and then decommission it. So this is the power of infrastructure as code. Imagine if these things should have been being done by manual approach, this wouldn't have even possible. So yeah, Tara, are we on time or? Okay. So guys, if you are seeing on screen, as I talk about Terraform, this is another use case which we are using. When you talk about your mutable infrastructure type of deployment, that was our Ansible, Puppet, and all those things. When we talk about immutable, and when you talk about Docker, containers, and Kubernetes, all things where we use Terraform for that. This is a simple file. Again, in a production environment, you will be using the entire practice of version controlling. This should be divided in modules so that which we called in software reusability of code. Same module can be used somewhere else. You just change some parameters, right? You do not have, every other team needs not to have define the entire file or everything. Then you can have workspaces in Terraform where the same code goes with some changes in development environment, in test environment, and production environment. So not multiple copy of code should be there. So your entire CI/CD pipeline set up in this way. So when we deploy anything anywhere, this is a configuration file for Terraform. So Terraform used HashiCorp configuration language. Now you might be seeing this is not some 1,000 line of code to deploy the entire infrastructure. This file is representing some sort of this environment, right? This will be now. Imagine if you are doing this manually, even in AWS environment, you are going to create a VPC that's up your private cloud. Consider it as your private data center, right? Then you have public subnet like other environment. You keep your web server in public subnet, your application DB server in private subnet, and then you install OS and then application, all those things, the developer requirement, and then multiple things happens. You have a net gateway to talk to the internet because your web and app and DB server won't directly be talking to your internet, right? Anything goes out of it, come into it. You want to upgrade your servers, it goes through net gateway, right? And there is an internet gateway. Now, had this been done manual, it would take around you a day to deploy everything. And then again, if you, in fact, decommissioning is one more aspect of it. You miss something, you are getting charged, right? In cloud, you cannot afford to miss something which is being charged. You have a clear picture of what is being decommissioned, and nothing should be left out. I would say in my personal account, when I was learning AWS, I created some load balancer, some net gateway or something. It's around $1, not very much costly, and it assigned an elastic IP to it when I was not working on Terraform or anything. So I missed that and destroyed the environment. At the end of the month, I receive around $30 bill. So this is what happens manually, and it was used for me. So consider this in a production environment where thousands of things are running. So this was the environment for which this code represents. You define a variable file. You give the if you are seeing this is pretty much any infrastructure or system admin guy can understand. This is not calling any class or then not creating any object or all those things. For in backend it is doing all of that, but that abstraction has been provided to you, right? Like in Ansible, we in fact, when you are using Ansible Tower, it's more easier to use again than to understand the entire code. So you are So yeah, so I have defined variable. You give your access key or secret key. You want to access your AWS environment. You have given all the details. As I talk in our image, we have the network designed, and the variable is also present. What should be the network, right? Now, basically, it is divided into. If you will see the major columns, major part of this is variable, providers, data, and resources, right? These are the only four major things in Terraform you should be learning. Yeah, again, when we talk about complete Terraform, it's a huge topic. So you define variable, you have provider. So what are the provider? The provider can be Azure, provider can be AWS, provider can be vSphere. You want to deploy, where you want to deploy, you just provide the provider. What are these? You just provide the details of your environment. You need to, how you need to access. Like in AWS, you have access key, secret key, right? You need to give those. In vSphere, you might be giving just your credential to access your vSphere environment. Network, when you create any VPC in AWS, you will have to give what network you are going to create for your, consider as creating a new data center, right? Then data, you want to fetch some details. When you are talking about completely automate, you are not bothered about what should I give completely, right? Data gives you something like that. It just fetches directly from AWS or provider, give you the option, and you can again code that it will automatically select the option. So data is basically fetching the data from your provider. So like in this case, it's fetching availability zones or something, your site in vCenter. Yeah, so again, all things, I'm not sure how many of are very well versed with AWS. Then I'm defining the internet gateway, subnet. You just see the way these are defined. You have just given the VPC ID, vpc.id, which is earlier been created. So again, using it, everything is automated. You are not going to fetch it manually, right? What resource is AWS subnet, right? Resource can be your VM, resource can be your network, right? So you are just creating these resources with simple coding. It's not again hard coding. If you start with the code with the basic, I think you can code it in a day or a couple of days. And when we talk about open sourcing everything, you can find these codes and multiple modules. Those are being pushed into GitHub daily, so you can utilize again the reusability of code. So yeah, we understand what are resources, the resources which you are going to provision. We have providers where you are going to provision it, and then you have variable defined, like anywhere in your PowerShell script, you define a variable, similar kind of variable it is. Then all those details which are intrinsic to VMware and any data center environment. So I have already, I'm not even defining here what should be deployed first, what should be the step. I would have followed Ansible, probably I would have defined deploy a VPC, deploy a subnet group, deploy an internet gateway, deploy a net gateway, attach a public IP to net gateway, and all things in a step, because Ansible is going to work in procedure, right? You miss something, and finally your environment will be built probably with some drift, right? And then you have to manually troubleshoot it. When we talk about immutable, you deploy it, you destroy it anytime. So again, you just install a Terraform on your laptop or somewhere. If you are using proper production environment, should be on your some server. So this is my folder where I have kept the code. You might see there's some security keys and all other things. For Terraform file, the file which I have opened, Terraform AWS, where I have kept all the code. I can keep now, when I talk about infrastructure as code, it should be kept on a version controlling system, right? But this is just for basic demo. Then you have variables defined in tf.var file. I'll open that as well. Don't worry, my keys, I will delete them as soon as I'm done with the demo. So these are the access key, secret key, similar to your credentials which you provide in your vCenter environment. I mean, This is something which is required to access the environment, right? And then you have tagging. Yeah, tagging, we have talked in VMware even heavily talked about tagging in vSphere 6.7 and 6.5. Even they have given some such features based on the tag in 6.7, right? Because tagging is one of the major aspect of maintaining an infrastructure as code, right? You are deploying multiple environment on your AWS environment or even your vSphere environment, and you are again using ISE, but you have not tagged it properly. So you are not, many times you will not be able to fetch the entire details of the environment. So tagging is one critical aspect, though a very small thing. So yeah, whenever I have installed Terraform on my server, it's I think some KB or MB1, MB or 2 MB file or something, zip file something, and easy to install. Okay, so whenever you create a folder, you do a Terraform. So we have a simple Terraform init, which is basically initializing all the provided plugins that, okay, I am going to talk to AWS. This I'm already in the source folder where my file is kept. The init will just initialize the plugins for the providers, right? So this should be your first step. It can, if your code has VMware, it will pull the plugins from VMware. Now, this is a plan thing, Terraform plan out equal to TF plan. What Terraform does it creates a state file. When we talk about descriptive or desired state, there should be some sort of mechanism which your software should be using that in which state your current environment is. So this is something plan does. It just fetch all the details. Initially, it's fetching all the details. Okay, we are going to deploy all these systems, and it will give you details what you are going to initialize, right? It will give you all the details. Same thing, it will keep in a state file, and the plan is doing the same thing. It's creating a state file. It will also create by default, but that's not a standard practice because when you destroy it, it will cause an issue. So, when we talk about immutable and idempotent infrastructure, uh, uh, how does this work? I mean, immutable, we talked about everything you deployed. When we talk about DevOps cycle, we talk about container, Kubernetes, and all other things. Uh, with you do not do any troubleshooting. Deploy the environment. Some container goes bad. It just checked whether everything is running fine as per the defined file, descriptive file. It sees, okay, one EC2 instance is down, but we need 7. It will automatically push the 7th one, right? Suppose you want to increase your environment in a procedural way. Procedural way, what you will do, you have an Ansible file. You have already deployed 10 server. Again, you want to deploy 5 more servers. You will have to check how many are deployed. Else it will deploy 5 new, right? So it will deploy 15 servers that way. In this case, when Terraform is maintaining the state file, you already have 10 server. Terraform has that state file that already 10 servers are there. You run a plan. Suppose server has gone bad and there are now 9 servers. So it will see one server is bad. I cannot fetch it. So one server is missing. You run again. It deployed the 10 server. And you want 15. You just take the instance count to 15. It again deployed 5 more server. It's not like it will again deploy 15 server, which will be in case of Ansible or any. See, you can see this 14 to 8, 0 to change, 0 to destroy, right? So it just fetch the state from my environment, from the region which I want to deploy, and it just check nothing is there. Everything needs to be added, all 14 resource needs to be added. You're not seeing any running instances. You won't see any VPC with that tag and other things. It's all clear, right? Yeah, I'm almost done. Yeah, so it's just fetching. I'm not sure if network is going through or not. Yeah. So you're seeing it started deploying all these things, right? It's just one file and deploying your entire, you can say practically your data center in the cloud or vCenter. You can roll back again when we talk about container. That's again a huge topic in that format. The Terraform works better in those environment when you talk about immutable infrastructure. So everything will be deployed, and probably it may take a couple of minutes. And same way, I can destroy the environment. So this entire thing I talked about infrastructure as code. Probably it may take a couple of minutes. Any question, guys? Anyone? Yeah, plan is basically fetching your details.
Yeah.
And yeah, plan is
So
not creating anything.
yeah, so it is executing the code, but not
Yeah, it's not.
implementing the changes.
Yeah, it's not creating anything.
Okay. Yep. Thank you.
You can catch Piyush during this break and ask so many questions. Anyway, you can go with one question. Yeah.
Yeah, last question. So as I see, you're deploying on AWS cloud. So through this Terraform code, in the backend, is it calling AWS APIs to?
Yeah, obviously, that's what I said. What Terraform has done, it has done nothing. It's given infra admin some power that even you can code. Probably it's got in the backend. I think it's created on Golang, which is doing all the work for you. And you are just having in the abstraction layer of HashiCorp configuration language, which talks in a very simple way. What do you want to create?
Okay, so Terraform abstract that.
Yeah.
So
Terraform is doing it for you. I mean, it just whether when we talk about vCenter, obviously vCenter is running some code to give you a hypervisor abstraction, right? It's doing the stuff the same way.
thank you.
Okay, guys. So anybody has any more questions?